wind turbine test in Boston, a town called Wakefield at the Sheraton Hotel. Blake Trueblood will be joining us, flying in from Las Vegas, where he's been meeting with 5 American Indian tribes, and throughout the weekend we'll be discussing with the inventors, the owners, and amongst ourselves to further solidify our plans. So, introductory shoot. Look forward to speaking with you throughout the coming weekend. Thank you for your time.
Hi.
Here we are.
Okay.
Greeting. Oh, fireside chat. Very nice. Rachel with the peace sign. Greeting. Mr. Stern, Mr. Trueblood, Mrs. Zani.
Frankly, the payback was good. I'll do it. That's what I'm going to say. I'm going to stream
Fireside chat.
Well, I'll tell you what, I decided if you bring my meal in, I'm going to stay right here.
Stan would like to dine here. Testing camera.
Frankly, the payback was good. I'll do it. That's what I'm going to say. I'm going to stream. If the payback was...
Blake, I'm going to zoom in on you. Let's check your complexion.
I look a little road weary.
You look good. You should sit up. Sit
I feel
up.
a lot better. I took about an hour nap and got cleaned up.
Get the chest out, Blake. Nice. Stan, I'm zeroing in on you.
I'd like to see if I did this.
Oh,
Okay.
very astute.
I'm very astute.
Very astute.
Frankly, the payback was good. I'll do it. That's what I'm going to say. I'm going to stream. If the payback was a bunch of, a few years, and you get a return of 33% where you come from, frankly, the payback was good. I'll do it. That's what I'm going to say. I'm going to stream. If the payback was...
Hi, Rachel Zani. Hello, how are you? Residing here at Wakefield, Hotel of Sheraton, very lovely. Actually, I spent a lot of time here at my college days in Newton, Massachusetts, which is a very lovely area. And as I grown into so many different verticals of markets and in the industries that I pursued, as well as fashion, marketing, advertising, and internet, I came to a realization that green energy is the way to go. And I'm very happy to be here, and I'm really looking forward to this project, pursuing to the highest end of success, and then that's the way it goes. Thank you. All right.
Let's get the pizzeria.
I was going to develop one time. I gave up after I checked and went online.
There, Rachel.
Hi.
All right.
Boy, am I hungry.
Morning.
How you doing, Sunday, right?
Been a while. Yeah. Good to see you.
Nice to meet you.
How are you?
All right?
Nice to meet you.
Thank you.
Hello.
How you doing? Good.
So just I talked to Larry. Have the battery drive turbine with the wind together. Right. So when cut that solar panel, when they cut, soon we have all the we go.
Let's try it.
Let's do it back.
It's extra heavy right now because it's the proto, so it's designed robust, if you will. No attempt to try to reduce the weight or anything else. You see, these are the housing. These are very heavy. One side, the other.
Go down and this is gonna. All this gonna change, then he's gonna have. Tell him what he's gotta do.
Yeah, there's the north side at a 20-degree angle. The air hits these blades at an angle this way. There's three of the blades are covered by the nozzle at any given time. The air coming out of the nozzle is sonic velocity. It's 1,000 feet per second. So at that speed, the air becomes non-compressible. It becomes like a solid fluid, or a fluid like water. So it develops a lot of energy. This rotor will spin at 22,000 RPM, or 20,000 RPM is about 22 horsepower. So that's what's going to drive the high pressure turbine and alternator to develop 17 kilowatts. That's what's used to charge the battery in the car during idle time or parking time. This design came out of the military. Out of the military. I was looking for a small turbine, and I hit upon a fellow Worcester that had done some work for the government, and they had developed this turbine for a government project, but then the government canceled it. They built a prototype and then they canceled the project. So he gave me the rights to the turbine. And then I just took the design and converted it into something that can be produced in volume. The ring captures the top part of the nozzle of a blade, and it prevents it from twisting, but it also locks it into the motor so that it can't fly out at high speed. Also, they're all keyed into the portion, this part of the rotor blade. There's a slot here, like a T-slot, and you load the blades through the opening, two openings here, and they slide along, and you just fill the whole circumference with these blades. There's 66 blades in here, and they're all locked in together so they can't twist.
Something like that. I mean, it looks like a watch. I was thinking of making that.
These were done here by
wow.
That's just the other housing. It's all hollow inside, and the two combination of that, this and the and no wider. This will reduce sounding weight quite a bit now, because it's a brand new design. I want to make sure that the robust enough that the blade didn't fly out. 22,000 RPM, right. Plus also the 22 horsepower.
Is there any danger of this not being lubricated properly, or how do you keep this from the wear and tear on this?
There is no wear and tear. Basically, the only wear and tear comes from whatever impurities there are in the air.
Okay.
Because it's basically like it would get sandblasted. If there was allowed to be any kind of impurity in the air that could affect the blade. But other than that, it's basically these are floating on just ball bearings. There's no physical contact between any of the parts other than through the coupling to the alternator.
So those ball bearings can handle.
Yeah.
All right.
And again, the ball bearings have to be rated for the torque.
Right.
And the life. Right.
What's the life cycle of those ball bearings?
The life cycle for the ball bearing is something in the order of like 20 years. They're rated for hundreds of thousands of RPM.
Okay.
Okay, say your names.
Santino.
Santino? And you're the developer of the wind turbine? Are you business partners?
Yes.
When did you develop the wind turbine?
About 2 years now.